Yeah, hi guys, welcome to the present video. So in this one we are going to see the state eligibility test for assistant professor paper 2 electronic science from Maharashtra one. So it is 26 September 2021 part 3. Part 1 and part 2 we already discussed in the previous video. So if you want you may check down in this YouTube channel guys. So let's start few of the questions from this part 3. So in the part 2 we saw the 8 questions, and coming to this 9th question. A Zener diode when used in voltage stabilization circuit so is biased in which way we are going to bias this one. So here the four options are there, you may check down. Option A, reverse bias region below the breakdown voltage, reverse breakdown region, forward bias to constant current mode. So basically if the Zener diode has to be work as a stabilization circuit, means it has to be operated in the reverse biasing. So C and D are the wrong one. And one more point is that whatever the reverse biasing voltage we are giving, it must be greater than the breakover voltage, okay, or else the breakdown voltage. Fine. So how can we justify that one means? So here I will tell you the simple three conditions of the Zener diode. So have a look guys. If you take any one Zener diode as like this, okay, and usually we are doing the reverse biasing for the Zener diode. So let's take the input voltage and it is a VZ. If the input voltage is less than the VZ, then what will happen? That means the input voltage is less than the breakdown voltage, then your Zener diode will act like a open circuit, nothing but a normal diode reverse bias condition. Okay. And if your input voltage is greater than the Zener breakdown voltage, then how it is going to act like that? Now the Zener diode concept will comes into the action here. Okay, that means it acts like a one constant voltage source. Okay, and now the equivalent of this diode can be taken as like this, and it acts like a VZ. That means if the Zener diode has to be act like a regulatory voltage stabilizer, means then your input voltage must be, or else your reverse biasing voltage must be greater than the breakdown Zener breakdown voltage. So in that aspect, below will not work out. We can call this one as a reverse breakdown region. So option B can be taken as a correct answer. Okay. And coming to the 10th question. So here the list 1 and the list 2 are there. So have a look here. In the list 1, donor energy level, Fermi level of the p-type semiconductor at room temperature, acceptor energy band, Fermi level in the intrinsic semiconductor. So if you look at this list 2, Fermi level in the intrinsic semiconductor is almost at the middle of the energy band gap, right? That means the D goes to 1. And coming to the acceptor energy band is nothing but a p-type semiconductor. So this level is very close to the valency band, and donor energy level is exist in the n-type semiconductor, it is close to the conduction band. And the Fermi level of p-type semiconductor at room temperature, so at room temperature it is so they are asking at room temperature, right? So room temperature means we are increasing the little bit temperature. Now what will happen? The more number of holes will be exist. If more number of holes are existing, then we can take that very close to the valency band, right? That means you must be very clear about here. C is acceptor energy band, okay, and B is the Fermi level of the p-type semiconductor. So comparing with both these two, if you are taking at the room temperature, then it will be a little bit closer to the valency band comparing with the normal 0 kelvins. Okay, so for this question we can take option D as a correct answer. Okay, next, in the circuit shown below in the figure, the power dissipated in the 30 ohms resistor will be maximum if the value of R is. So generally we know that if the value of the it is a maximum power transfer theorem concept, right? So if the maximum power has to be delivered to the load, then what we are calling is that the source resistance must be equal to the load resistance, then only it will be the maximum, right? But whenever the variable resistance is given in the circuit, okay, variable resistance is given in the circuit, then the maximum power transfer theorem will not be applicable here. So you can take this R as a 0. Got it? You can take the R as a 0. That means here to get the maximum the power has to be delivered, then the value of the R can be taken as 0. So option D is the correct answer. Most of the people will calculate the parallel resistance, and that will equate it to the 30 here. Okay, so that is not the, and if you do like that, you will get nearly 30 ohms guys. But the variable resistance concept is not applicable in the case of maximum power transfer theorem. So we can take option 0. That is option D as a correct answer. Right? Next. A network has 10 nodes and 17 branches. The number of different node pair voltages would be. So to find out the node pair voltages, okay, so if you have the formula, then you just find out, guys. Otherwise, make a note of the formula. So here the branches is not required to find out the node pair voltages. Okay. So the number of node pair voltages concept can be taken as n into n minus 1 by 2. Okay, we can take as like this. N into n minus 1 by 2, where n represents the number of nodes here. Okay. And how many number of nodes are given in the given question? 10 number of nodes are given. So 10 into 10 minus 1 divided by 2, that is equal to 10 into 9 divided by 2, that is equal to 45. So in this question we can take this option C as a correct answer, that is the number of node pair voltages. Okay. And apart from this one, you should know about all the concepts regarding the network graph theory, about the tree, graph tree, code tree, twigs and links. Okay, the number of branches. Okay, so with given number n, so how many number of branches can be taken, right? So all these and what about the instance matrix, cut set, tie set matrix, what is the rank of all these three matrices? Okay, so get the concept of all these things, guys. Very, very important. Coming to the next question here. Consider the following energy storage capability of the basic passive elements is due to the fact that, okay, so resistance dissipates the energy. Of course, resistance dissipates the energy in the form of what? Heat. And capacitor stores the energy. Of course, the capacitor stores energy in the form of charge. And inductor dissipates the energy. Inductor will never dissipate the energy, guys. Inductor will induces the energy in the form of magnetic format. Okay, magnetic energy. So out of all these three options, here the option 3 can be taken as wrong one, and we can take 1 and 2 as a correct answer. Okay, that is resistance dissipates energy in the form of heat, capacitor stores energy in the form of charge. Okay, and coming to the next question. So FIR filters. Okay, actually here digital filters has to be there. Okay, anyhow, so finite impulse response and the infinite impulse response. Here they given the options regarding the recursive and the non-recursive. Okay, and you may check down that here the recursive, where the present output depends upon the present and past input and output samples only. Non-recursive is nothing but present output depends upon the present and past input samples only. And recursive, the present output depends upon the present and past input. Non-recursive is nothing but present output depends upon the present and past input and the output samples. So I will show you the differences between the recursive and the non-recursive, guys. You may check down. So usually the digital filters, the two types are the FIR and the IR filters. So coming to the FIR filters can be taken as a non-recursive, and infinite impulse response filters can be taken as a recursive type of filters, that you may check down. FIR are the non-recursive and IR are the recursive type. So wherever the recursive type of filters we are taking, then the present output depends upon the present and past inputs as well as the outputs. You may check down the equation here. The present output, that is y of n, depending upon the past output and the past input also. It is called as a recursive. Okay. So the definition itself they mentioned here. So you may check down, guys. Recursive type of filters, present output depends upon the present and past inputs as well as the outputs. And while coming to the non-recursive type of filters, the present output depends upon the present and past inputs only. Okay, so based upon both these two definitions, you may take out of the ABCD which one is the correct answer. Okay, and a few more questions we'll see in the next session, guys. Okay, next part. And if you are not yet subscribed the channel, then please do subscribe, guys. Okay, and try to share this video links in your groups also. So try to maximize the views as max as possible you can. Okay, thank you very much.